Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to be talking about a concept that does show up from time to time on the ASVAB. That is how to find the percent change. Before I do that, I quickly want to mention this. In case this is your first time finding my YouTube channel, I want to mention that I recently created a website called mastertheasvab.com. There you can sign up for an account and take up to 9 practice tests. All that said, let's get started with today's video. As I mentioned, today's video is in regard to determining the percent change. And I'll first want to point out that it's very easy to do this insofar as long as you know this formula, that is percent change equals final amount minus original amount over original amount times 100. As long as you know this formula, you should be able to do any of these problems. Before I go into a practice problem, or before we start the practice problems, I just want to simplify this formula for you. This is how I write it because I don't like memorizing all this. I say percent change equals final amount minus original amount over original amount times 100. Okay, so if you take a look at my YouTube channel, you'll see that I've created videos for certain formulas that you absolutely have to know to do well on the ASVAB. For example, I've discussed the distance formula, which is distance equals rate times time. I've discussed simple interest, which is I equals PRT, among a number of different formulas. Well, this right here is something else that you should commit to memory. The reason being is this. When I take the ASVAB and I see a problem like this, the first thing I do is I write down this formula, and then the problem just becomes a matter of plug and chug. That is, I identify what part's what, and then I just use very basic arithmetic skills to solve the formula. So all that being said, commit this one to memory, but let's get started with the practice problems. And I believe there are 6 of them. Each of the practice problems is going to test your ability to do different aspects of arithmetic. For example, you're going to see that you're going to have to be able to multiply and divide fractions, reduce fractions, multiply and divide negative numbers. So this video, if you watch it from start to finish, will also be a great refresher as to how you do those very basic arithmetic sequences to solve bigger problems like these. So question 1 says Keela's clothing store buys coats for $50 and then sells them for $80. What is the percent markup on the price of the coat? So again, these questions are always going to ask you to find the percent change. So as soon as you see percent, you know you're dealing with this formula. So again, I see it's asking me to find the percent. The first thing I'm going to do is percent change equals final amount minus original amount over original amount times 100. Okay? Always write down the formula first. It will help you, as you'll see in just a minute, keep your work very organized. And when your work's organized, you typically don't make many mistakes. So now, with the formula written down, we got to identify what the final and original amounts are. So the clothing store buys the coat for $50. So that's the original amount we pay for the coat, and sells them for $80. That's the final selling price of the coat. So with those 2 things identified, we can go ahead and plug them into the equation. Again, final is 80. Original, as I just mentioned, is 50. Original is 50. And this, of course, is all multiplied by 100. This first one's fairly easy. 80 minus 50 is 30 over 50 times 100. Now there's a trick as to how to do how to reduce these fractions when there's corresponding zeros. What you can do is just cross out the zeros accordingly. So this becomes 3 over 5 times 100. So now we have to do some long division because all fractions can be regarded as division. So 3 over 5 is the same as 3 divided by 5. So I'm going to work that off to the side. 3 divided by 5. 5 doesn't go into 3 because 3 is too small. So that prompts me to add a 0 here. When I add that 0, I have to bring up a decimal. Okay? 5 goes into 30 6 times. 5 times 6 is 30. So we can see there's no remainder. Okay? So let's go ahead and substitute 0.6 for 3/5. And now we have to do additional arithmetic, namely 0.6 times 100. While anything multiply or divided by a power of 10 is very easy to do, let me do this off to the side. We have 0.6 times 100. The easy way to do this is to recognize that anything times a power of 10, which 100 is in this case, we just shift the decimal place according to how many zeros there are. So in 100 there's 2 zeros. So I'm going to take this decimal place and shift it 2 times. So that's going to take 0.6 to 60. So this is going to be 60%. So in other words, the clothing store has a 60% markup on this particular item. Okay? So those are all the steps for finding the percent change. Let's take a look at the next problem because it has a slight variation on the formula. So number 2 says Jack's average in math for the first 9 weeks was an 88. His second 9 weeks average decreased 12.5%. What was his average for the second 9 weeks? So again, instead of asking us for the percent change, it's asking us for the average. That said, we should recognize that we're going to need to use the percent change formula to solve this one. So let's go ahead and write that down. Percent change equals final amount minus original amount over original amount times 100. Okay? Now, let's see. We're told that the first 9 weeks was an 88. So that's our original amount. So we're going to plug that in for O in the formula. His second 9 weeks decreased by 12.5%. So that's the percent change right here. This is our PC. And we want to find out what his average for the second 9 weeks was. So that's going to be our F. So instead of solving for percent change, we're actually solving for F in this case. So let's go ahead and plug things in accordingly and see what that looks like. Again, percent change, it went to 12.5%. So that's our percent change. It actually decreased by 12.5%. So this is going to be negative. The final amount, we don't know. So we're going to leave that as F. The original amount was 88. So we fill that in those two spaces accordingly. And then we multiply by 100. So you might be saying to yourself, what do I do at this point? Well, we're trying to solve for F. And to do that, we have to get rid of this 188. The first thing I'm going to do is the opposite of this. This is multiplied by 100. So I'm going to divide everything by 100 here. So this is going to cross out there. When I do to one side, I have to do to the other side. So I'm going to divide that by 100 as well. So that looks like this. Let me clean this up a little bit. We have negative 12.5 over 100 equals F, final amount, minus 88 over 88. Okay? Now, again, when you multiply or divide something by a power of 10, it's just a matter of shifting the decimal place. In the first problem, we multiplied by 100, so we shifted the decimal place to the right twice. In this case, we're dividing by 100, which has 2 zeros, so we're going to shift this decimal place 2 times. So without doing any difficult long division, I know negative 12.5 divided by 100 is just going to be negative 0.125, and we're left with F minus 88 over 88. Okay? Now we want to focus on getting f by itself again. So the next thing I'm going to do is get rid of this 88 in the denominator. So I'm going to multiply both sides by 88. This crosses out here. And that leaves me with 88 times negative 0.125 equals f minus 88. Okay? So before we can do anything else, I want to simplify 88 times negative 1.25. In case you haven't worked with negatives and positives in a while, let me go ahead and put up the signs chart real quick, just as a reminder. And the way this works is, the signs chart is good for multiplication and division. The way it works is you identify what's going on. We have a positive number, so we work here, times a negative right there. So we know the product is going to be negative. So positive times a negative is a negative. That said, we do need to work this one off to the side since it's not something most people can do in their head. We have negative 0.125 times 88. Okay? That is, we're multiplying a decimal by a whole number. The trick to doing this one is to make this decimal a whole number by shifting its decimal place accordingly. We're going to shift this one 1, 2, 3 times to the right. So in reality, I'm doing 125 times 88, albeit with 3 decimal places to shift back in at the left at the end. Okay? So let's work this out. And again, the result's going to be negative. We know that already from the signs chart. So that's why I dropped that negative there. I know the product's going to be negative. So let's work this out. 5 times 8 is 40, carry the 4. 8 times 2 is 16, plus 4 is 20, carry the 2. 8 times 1 is 8, plus 2 is 10. We're moving to this number, so we add a 0. 5 times 8 is 40, so we carry the 4. 8 times 2 is 16, plus 4 is 20, carry the 2. 8 times, and let me move this negative out of the way real quick. 8 times 1 is 8, plus 2 is 10. Okay, let's add these. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus nothing is 1. Shift our 3 decimals back in. 1, 2, 3. Again, we know this is negative. So 88 times negative 0.125 is negative 11. And again, this is f minus 88. So now, again, we're still trying to solve for f. We're not quite there yet. We had to do a lot of arithmetic to get to this point. So we're going to add 88 to both sides. This crosses out. We're left with f equals 88 minus 11. Let's work that off to the side. 8 minus 1 is 7. 8 minus 1 is 7. So f equals 77. So to answer this question, let's take a look at the question again. What was his average for the second 9 weeks if it decreased by 12.5%? Well, it went from an 88 average to a 77 average. Okay, and that would be the final average for the second 9 weeks. The 88 average was for the first 9 weeks. Okay, so a lot of tedious work for that one, but fortunately enough, not all of them are this time consuming. Again, as long as you're good with arithmetic, basic algebra, and you know the formula, you should be able to solve any one of these. Okay? So let's move on to number 3. Number 3 says in 1967, a 30-second Super Bowl commercial cost $40,000. In 2000, a 30-second commercial cost $1.8 million. What was the percent of change in the cost of a commercial? So again, they're asking you for the percent of change. That should trigger you to right away write down the percent of change formula. Percent of change equals final amount minus original amount over original amount times 100. Okay. And we start plugging things in accordingly once we identify them. Again, 1967 costs $40,000. That's our original amount. 2000, it's 1.8 million. So that's our final amount. And that's all we need to get started. So we got percent change equals final amount, 1.8 million, minus original amount, that's 40,000, over the original amount, that's 40,000, all times 100. Okay. So now this one's straightforward, but the snag is we're working with pretty big numbers. The first thing I'm going to do is do 1.8 million minus 40,000, and of course, so as not to make any mistakes, I'm going to do that work off to the side. So we got 1.8 million minus 40,000. 0 minus 0 is 0. 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 0 minus 4 I can't do, so I have to borrow. This becomes 6. This becomes 10. 10 minus 4 is 6. 17 minus nothing is just 17. So we've made one step. We're one step closer to solving this. Again, 1.8 million minus 40,000 is 1,760,000, which is right there. This is all over 40,000, and it's all times 100. Okay. Now, as I did in the first problem, we can cancel some of these zeros to make this math a little easier. So we're going to cancel zeros correspondingly. I'm going to cancel this one and this one, this one and this one, this one and this one, this one and this one. So let's go ahead and write that now that it's simplified. We have 176 over 4 times 100. Again, that's much easier to do. Now I'm going to work out this long division. Again, all fractions can be regarded as a long division. 176 over 4 is the same as 176 divided by 4. So let's go ahead and do that. 4 doesn't go into 1. 1's too small. 4 goes into 17 4 times without going over. 4 times 4 is 16. 17 minus 16 is 1. Drop down this 6. 4 goes into 16 4 times. 4 times 4 is 16, so we can see there's no remainder. So I know 176 over 4 is 44. Again, that's times 100. So again, whenever we multiply something by a power of 10, which 100 is, we just shift the decimal place according to the number of zeros in that power of 10. The decimal place is right here technically, and let me write this off to the side. The decimal place is technically right there on 44. There's 2 zeros in 100, so we shift it 2 times. So we can see the percent change in this case is going to be 4,400% increase. Okay? And as you can see, you would expect that large number since you went from 40,000 to 1.8 million. So this is a reasonable answer. And you can see all the work it took us to do it. Okay, so that's that one. Again, we're just manipulating the percent change formula to solve these, which requires arithmetic, including multiplication and long division, and addition and subtraction. So this is a good review of all those concepts. All right, number 4 says a manufacturing company with 450 employees begins a new product line and must increase their number of employees by 18%. How many total employees does the company have now? Okay, that's a good question. So again, we know we're dealing with percent change, and that's always final amount minus original amount all over original amount times 100. And I think this question's written bad because it says how many total employees does the company have now? Well, it tells us that it has 450 employees. So what it's asking is how many employees will it have with the 18% increase. Okay, so just bear with me on that. So again, percent change. Let me go back a little bit. The percent change is going to be 18%. This question says they want to increase the number of employees by 18%. Okay? So that's going to be 18 for percent change. The final amount's what we're asking for, so it's going to be F. Right now, the company has 450 employees, so that's our original amount. So we're going to go F minus 450 over 450 times 100. And again, the first thing I'm going to do is get rid of this 100. We're trying to solve for F, so we're going to have to get rid of this 100 first and then this 450. To get rid of the 100 first, we divide everything by 100. Again, this says this times 100, so we're going to do the opposite. We're going to do that to both sides. This crosses out. We're left with 18 over 100 equals F minus 450 over 450. Okay. And so, again, this is not hard to do. We're dividing 18 by 100, which is a power of 10. The decimal place is right here. We're just going to shift it according to how many zeros there are in this power of 10. There's 2 zeros, 1, 2. So 18 simply goes to 0.18. And again, that's how you do that math pretty quickly. So we're left with F minus 450 divided by 450. Now the next step is to multiply both sides by 450, since we're trying to get F by itself. This crosses out. We're left with 450 times 0.18 equals F minus 450. Again, the goal is to solve for F, the final amount, how many employees it has now, assuming there was an 18% increase in the company's staff. So the next thing I want to do is work this out. That is, I want to find out what 450, a whole number, times 0.18, a decimal is. And again, that looks like this off to the side. Again, we're multiplying a whole number by decimal. The trick, as I mentioned in the other problem, is to make the decimal a whole number. In this case, we have to shift the decimal 1 2 times. And so in reality, I'm working out 450 times 18, albeit with 2 decimal places to shift back in at the end. Okay, so we have 0 times 8, that's 0. 5 times 8 is 40, carry the 4. 4 times 3 is 32, plus 4 is 36. Add a 0 since we're starting this number. 1 times 0 is 0, 1 times 5 is 5, 1 times 4 is 4. Let's add. 0 plus 0 is 0, 0 plus 0 is 0. 6 plus 5 is 11, carry the 1. 4 plus 3 is 7, plus 1 is 8. Shift our 2 decimal places back in. 1, 2. So 450 times 0.18, as we can see right here, is going to be 81 equals F minus 450. So now we're solving for F. We're going to add 450 to both sides. Again, we're doing the opposite of what's going on there. It's subtracted, so we have to add to both sides. This crosses out. We're left with F equals 450 plus 81. Let's do that off to the side so we don't make any mistakes. 0 plus 1 is 1. 5 plus 8 is 8, 9, 10, 11, 12, 13. Carry the 1. 4 plus 1 is 5. Okay? So, in other words, if the company increased its staff by 18%, it would currently have 531 employees. Okay, so that's that one. The question just wasn't worded that well, so I apologize for that. Number 5 says Shannon had 765 cards in her baseball collection. She sold 153 of those cards to purchase a new iPod. What is the percent change in the number of Shannon's baseball cards collection? So again, we have to understand that we're working with percent change. So regardless, we're going to be using percent change equals final amount minus original amount over original amount times 100. Okay. And now we got to identify what to plug in where. She has 765 cards in her collection, so that's the original amount. We know she sells 153 of the cards to purchase a new iPod. So let's figure out what we're going to do for this final amount. So we got percent change equals final minus 765 over 765 times 100. So the way this is going to look, let me think about this real quick. There might be an easier way to do it. So the percent change here is going to be negative because she sold. It's going to decrease. So her percent change is going to be negative some odd percent. Okay. So to find the difference in this, we're going to do this: 765 minus 135. 5 minus 5 is 0. 6 minus 3 is 3. 7 minus 1 is 7 minus 1 is 6. So let me show you what I'm talking about here, because I want to point this out, because this is a little bit tricky. This is going to be 630 minus 765 over 765 times 100. Okay? Now what I want to point out by doing this is this. This is going to be the amount of 630 is the amount of cards she has after she sells 153 of. Oh, I did 135 there. Let me fix that. It's not going to be 630. Bear with me here. And it's very easy to make these mistakes as you're trying to think your way through these problems. So again, she went from 765. She sold 153 of them, not 135. So let's redo that. 5 minus 3 is 2. 6 minus 5 is 1. 7 minus 1 is 6. Let me just check. 2, 1, 6. Okay, so that's right. Sorry about that. So what this says is after selling 153 of her baseball cards, she has 612 left. Now, I don't have to do this math. I don't need to know what 612 minus 765 is, because I know it's going to be negative 153. 612 minus 765 is going to be negative 153 over 765 times 100. Okay, so now all I have to do is solve this accordingly to find the percent change. Again, let's go back to the signs chart if we need to. Positive times a positive is a positive. Positive times a negative is a negative. And negative times a positive is a negative. Negative times a negative is a negative. And this also works for division. Positive divided by a positive is a positive. In this case, we have a negative, which is right here, divided by a positive, which is right here. So I know this result's going to be negative, which is why I know that this is going to be a percent decrease. So that's expected. Okay, so let's work this out. The first thing I want to do is regard this fraction as a long division, namely 153 divided by 765. I know the quotient, or the result of doing this long division, is going to be negative, so we can go ahead and tack that negative on right there, since we already know what the result's going to be. Now I'm asking myself, how many times does 765 go into 153? It doesn't. 153 is too small. I have to tack on a 0 there. By tacking on that 0, I have to bring up a decimal. Now I'm asking myself, how many times does 765 go into 1530? Well, it's either going to be once or twice, because think about this. 700 times 1 is 700. 700 times 2 is 1400. I'm going to say 765 times 2 is going to get me pretty close to this. 5 times 2 is 10, carry the 1. 6 times 2 is 12, plus 1 is 13, carry the 1. 7 times 2 is 14, plus 1 is 15. So we can see 765 goes into 1530 twice. And 765 times 2 is 1530, so we know there's going to be no remainder. So in other words, and I'm going to start shifting it over this way, percent change equals, again, this is a negative 0.2 times 100. Percent change equals, again, anything times the power of 10, which 100 is. We just shift according to how many zeros there are. There's 2 zeros in 100, so I'm going to shift this 1 2 times. So that negative 0.2 becomes negative 20%. So by selling off 153 of her baseball cards, the total amount in her collection decreased by 20%. Okay? And that's all the math you need to get to that. Again, this is the sticking point for most people, because they didn't necessarily give you the final amount, but you can find the final amount, and then you have to realize that that final amount minus the original amount is going to be negative, because the percent change is going to be decreasing. Okay, so that's that one. All right, number 6 says Caroline, an employee of Hollister, bought a sweater originally priced at $55 for $38.50 after her employee discount. What percent off is the employee discount? So again, we're being asked to find the percent change, so that's going to be percent change equals final amount minus original amount over original amount times 100. Again, it was originally priced at $55, so that's our original amount. It's sold for $38.50, so that's our final amount. And we want to find out how much our discount is. Again, this one's going to be negative as well, because $38.50 minus 55 is going to give you a negative number. So let's see what that looks like. Percent change equals, again, the final amount was $38.50 minus the original amount, 55 over 55 times 100. Okay, so that's that. With this setup, we can go ahead and work our way through it. We have $38.50 minus 55, so I'm going to do it this way. 55 minus $38.50. I know the result's going to be negative, but this just helps me keep my math straightforward. 0 minus 0 is 0. 0 minus 5 I can't do, so I have to borrow from here. This becomes 4. This becomes 10. 10 minus 5 is 5. Drop your decimal in place. 4 minus 8 I can't do. I have to borrow. This becomes 4. This becomes 14. 8 and 14, that's going to be 6. And 4 minus 3 is just 1. Okay? So in other words, I know $38.50 minus 55 is going to be negative $16.50 over 55 times 100. We want to find out what her employee discount is. So now we're at this point. We got to do negative $16.50 divided by 55. Again, all fractions can be regarded as long division. In case you need it, here's the signs chart. Positive divided by positive is positive. Positive divided by negative is a negative. Negative divided by positive is a negative. Negative divided by negative is positive. In this case, we have negative 1650, which is right here. Positive 55 was right here. So we know our result's going to be negative, so we can go ahead and throw that up there. Now the question is, how many times does 55 go into 1650? Or 16.5, it doesn't. So I have to shift this decimal place one time to make it 165. In so doing, I have to bring the decimal place up here. Now the question is, how many times does 55 go into 165? 50 times 3 would be 150, so I'm going to say 3 times. 55 times 3. 5 times 3 is 15, carry the 1. 5 times 3 is 15, plus 1 is 16. So as we can see, 55 times 3 gets us 165 even, so that there's no remainder. So in other words, this is going to be percent change equals negative 1650 divided by 55 is negative 0.3 times 100. Percent change equals negative 0.3 times 100. Again, we're multiplying by a power of 10, which has 2 zeros. Shift the decimal place 1, 2. So we can see that her discount decreased the price of the item by 30%. So her discount is in the amount of 30%. Okay? So again, that's all I have for this video. Doing these questions is pretty tedious, but as you saw, as long as you know this formula and can plug things in the right place, none of these problems should be too difficult. So as always, feel free to like this video if you found it helpful. Feel free to share my content and leave some feedback in the comments section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.